Dear students, welcome to Elate Classes. Today we are going to discuss on the topic XT, VT and AT graph and its physical significance from a chapter Rectilinear Motion. This video is part of the lecture series that we are providing from Elate Classes. Elate Classes is located at Dhonai Bora Chowk of Sipajhar. Students who want to join in our offline classes, they can contact us in the contact numbers given in the description box of this video. Let us now proceed with the today's content. Okay, let us now start with the displacement time graph. The displacement time graph represents how displacement x varies with time when an object is in motion. The physical significance of this displacement time graph is the slope of the xt graph gives us velocity of the object during its motion at different instants. Okay, now let us discuss the displacement time graph. I have drawn a displacement time graph, and on this graph at different instants I have drawn some tangents. Now as per this xt graph, the object has started its motion from the position A, that is at t equal to 0. The position of the object is at A. Now if I have to find out the speed of the object when it is at A, I am going to draw a tangent at A. Now the slope of this tangent will give me the velocity of the object. Now if the slope is positive, velocity will be greater than 0, and if slope is negative, velocity will be less than 0. Now as you can see, already it is shown at A and at B slope is positive, that means velocity is greater than 0. At D and E slope is negative, that means velocity is less than 0. Now we know velocity is a vector quantity. Velocity has magnitude as well as direction. The magnitude of the slope will give us the magnitude of the velocity, that is the speed, and the sign of the slope, whether slope is positive or negative, that will decide whether the object is moving in the forward direction, that is in the positive direction, the direction which is assumed as positive, that direction, and if slope is negative, that will mean that the object is having a negative velocity. Negative velocity meaning is the object is moving in the negative direction. Now you see, as I told you, at A slope is positive, so velocity is greater than 0. Now I am going to draw this equation in the motion diagram. Now it is already shown in the motion diagram. At t equal to ta, that is equal to 0, the object is here, that is in some negative x. Now from here, because we are talking about a rectilinear motion, in actual the object is moving along a straight line. So let us say this is the path of its motion. Initially when the object is at A, let us say the object is somewhere here, that is at t equal to ta equal to 0, the object is somewhere here. Since here the slope is positive, that is why velocity is greater than 0. Now when velocity is greater than 0, the meaning is the velocity greater than 0, the means the object is moving in the positive direction. That means the direction which is assumed as positive, the object is moving in that direction. Now why this slope is positive mathematically? This slope is positive because this tangent is making a angle with the horizontal less than 90 degree. Now we know slope is nothing but tan of theta, and tan theta value, it increases from 0 to 90 degree. Now in this case, since theta is less than 90 degree, it will give me a positive tan theta value. That means my slope is basically positive because tan theta is positive, so slope is positive. If slope is positive, the meaning is, because we already know from the physical significance that slope gives us velocity. So if slope is positive, that means indirectly velocity is positive. Now velocity positive means the object is moving in the positive direction. That means direction which is assumed as positive, the object is moving in that direction. Now the object is having these positions during its motions as it is shown here in the xt graph. So after some time, when the time is t equal to tb, the object crosses its reference point, that is its origin. Now here at t equal to tb, object is at reference point. The meaning is, now if the object, when it is moving further, it is moving towards the positive x direction from negative x side. Now this situation can be explained from the motion diagram. At t equal to tb, the object is at x equal to 0, that is at the reference point, that is at the origin. Now direction of the velocity, how we have got this direction? Again from the slope. Now the tangent at B is the slope of the tangent is positive. Again the same explanation. Here also this tangent is making an angle of less than 90 degree with the horizontal. So again tan theta will come as positive because from 0 to 90 tan is positive. So indirectly the slope is positive. If slope is positive, because slope itself from the physical significance we know gives, slope itself is the velocity in the xt graph, that means velocity is positive. And since velocity positive means velocity has magnitude as well as direction, positive means the velocity is, the motion is in the positive direction. The motion is in the positive direction. Now you see, during its motion, when it reaches B from A, the speed is increased. Why speed is increased? Because from here to here, the slope of the tangent has increased. So from A to B, the speed actually is increased. Now from B to C, the speed is decreasing. And eventually at C, the speed becomes 0. The reason is the tangent at C is making a slope of 0 because here the tangent is a horizontal line. The tangent is parallel to my time axis. That is why the velocity here is 0. Now this also can be represented in the motion diagram. Let us now draw the motion diagram for this position. Now let us see at position C. At position C, as you have already got, the velocity is 0 because slope is 0. This situation let us now see in the motion diagram. In the motion diagram, as you can see, the object is at its extreme positive position, that is extreme positive x position. That means the object was initially started here, then at t equal to tb it came to the origin, and at t equal to tc the object has arrived at its extreme positive x position, and here the object momentarily stops, and from there now let us see how it further proceeds as per this xt diagram. Now from here to here the velocity is 0, here the velocity is negative velocity. Now why it is negative? Because the slope is negative. Why slope is negative? The tangent, it makes an angle which is larger than 90 degree. Now since we know slope is equal to always tan theta, but here the angle which this tangent is making with the x-axis is 90 plus theta. So for this case, my angle is tan 90 degree plus theta. Tan 90 degree plus theta. We know when from trigonometric concepts, when this 90 degree is odd multiple, what we write? We transform this tan into cot theta. And again, according to ASTC rule that we learned in trigonometry, this is 90 plus theta is in the second quadrant, and in the second quadrant tan is negative, only sign is positive as per ASTC rule. That is why my slope will be negative. Thus the value of slope will be a negative value. Now since slope is negative, from the physical significance of the xt graph, slope means the velocity of the object, and since slope is negative, that means velocity is less than 0, this velocity is negative. Now what does it mean in the motion diagram when velocity is negative? Velocity is a vector quantity, it has magnitude as well as direction. Direction actually is the cause which decide whether velocity will be positive or negative, because velocity is a vector quantity. So since velocity here is negative, less than 0, that means obviously the object is now reversing its direction. That means from here object is now moving in the negative x direction, which is my negative assumed direction. Now the object is somewhere here. Now velocity here is Vd. Velocity here is Vd. And why it is negative or less than 0? Because the object is now moving in the negative x direction. So slope of the tangent at D and slope of the tangent at E, both are negative slopes. Both are negative slopes. But since both these tangents are making an angle of 90 plus theta, so slope becomes minus cot theta. For both these cases, here the value will be higher negative value at D than at E. That means velocity is more negative here than at E. That means the magnitude of the velocity, although it is moving in the negative x direction, it has higher velocity here than at E. But both at D and E, the object is moving in the negative x direction. This is the position of the object in the motion diagram when it is at D, and when it is at E in the motion diagram, it will be somewhere here. It is closer to my origin. That is, it is reaching the time axis. Let us now see some important interpretations of xt graph. When the xt graph is a straight line with constant slope, it represents uniform or constant velocity motion. Now let us see this graph. In this graph, I have drawn a straight line with constant slope. So, since this is a straight line, at any time instant, if you see, this straight line will have the same slope. Since the xt graph, in the xt graph, slope represents velocity, and we know a straight line has single slope. That means slope is same anywhere you take, meaning is the velocity is going to be same at all time instants. That is why a straight line with constant slope represents uniform velocity. Again, if the xt graph is a horizontal line, what does it mean? It means the object is at rest. Why? Now you see this figure. In this figure, I have drawn a horizontal line. This horizontal line represents the position of the object with time. Now since the position is not varying with respect to time, it is along this line itself, which is parallel to the time axis. That means position is not varying because position is in the vertical axis and there is no shift in position in the vertical axis. That is why in the entire time frame, the object is along this horizontal line itself. That means the object is not leaving its position. That means the object is at rest. So the next interpretations from xt graph is when the xt graph is a curved line, it represents accelerated motion. Now let us see how it represents accelerated motion when it is a curve. Now you see in this xt graph, which is a curved line, if I take two arbitrary points A and B and if I draw two tangents, both these tangents, as you can see, have different slopes. Since the two tangents have different slopes, that means at point A and at point B, the velocities are not same because slope of the tangent in the xt graph represents velocity, and since from the visual inspection I can see that slope here is different than this, that means velocity here and velocity here are not same. Since they are not same, this velocity is changing. That means this graph represents accelerated motion. The next interpretation of xt graph is xt graph with steeper curve. Now you see these two curves are representing two different motions. Say this graph is representing motion of one object and this graph is representing motion of another object. Now, just like this, if you draw tangents at different positions, the tangent at every instant for this motion, for this object, will have different velocities. Similarly, if I draw tangents on this curve at different instants, I will get different velocities. But if you compare the corresponding slopes at different time, let us take this as a time instant. Now if I draw a tangent here, this tangent will have smaller slope than the slope of this tangent, That means when the curve is steeper at the same time instant, the slope is higher. That means velocity at the same instant here on this curve. That means for the second object at the same time instant, the object is at higher velocity than the object whose motion is represented by this graph. That means the steeper curve represents higher velocity. It represents higher velocity. Okay. With this, we can conclude the important concepts of XT graph. We will now continue with the VT graph, and then we will discuss some important questions from previous year's NEET and JEE from XT graph as well as VT graph, and then we will study the important concepts of AT graphs.